Hi everybody, Nick Smith here. I've had a question from one of our users to ask me to try to explain the photometry, particularly to do with sports lighting. But I'm going to touch on a couple of the small issues that you may or may not come across as part of sports lighting design. Now, firstly, I would say sports lighting can be complicated, particularly if you're doing stadium lighting, and there's broadly two levels of lighting that you're looking at. The first one is your lighting for the players, what I would perhaps call recreational sport, and then you get larger event lighting where you're lighting for the television cameras. And if you are not experienced in doing lighting design for sports lighting, please don't try and do stadium lighting. Get somebody involved who knows what they're doing. It's very, very easy to get it wrong. So here endeth the lesson. Okay, so we're going to look at a couple of small projects. So I'm going to look at a small project and talk about a few of the issues. Now, the first thing to bear in mind is that all of the manufacturers who produce sports lighting product should be providing you with some kind of PDF download or better still or a paper catalogue. This happens to be the Abacus one. So if you want to go look at that, and I'm looking specifically at asymmetric floodlights here. So and what you will often see is curves like this, which are known as Cartesian curves. And broadly speaking, there are two or three methods of displaying the photometry to see how it performs. So these diagrams are obviously quite small unless you've got a PDF viewer and you can zoom in and take a closer look at them. It's difficult to see what's going on, but broadly speaking, we generally have two distributions from a lantern. The first one is perpendicular to the column. So if you drew a line from the column straight out into the pitch, this is the distribution that you would get. And what it is showing us is that we've got a peak distribution here at about, well, that's 50 degrees, that's 60, that's 70, so probably about 58 degrees is the peak output of the fitting, which means if you mount that fitting horizontally, the distribution, this peak, this high level, will come out at 58 degrees. Now, if you go back to methodology with school and look at trigonometry, the higher the mounting height, the more that distribution will go across the pitch. So, and in sports lighting, it's very common to use 12, sometimes 15 metre columns, 16 sometimes with rugby, and we can go up to 18, 20, 25. You can go pretty much as high as you want, and obviously speak to the column manufacturer and see what they can actually provide to you. So the blue distribution, or this sort of bluey-grey distribution, is the distribution output perpendicular to the fitting, and this to the column, sorry, and this red distribution is the output that is parallel, so it's showing you the distribution left and right. So this is where the lantern is, and it's showing you what is going out both sides of the particular fitting. Now, if we go and look at a light source within a software, I'm using Lighting Reality because it shows it off really well, the different methodologies, but here you can see we've got a slightly different distribution, and I'll explain why that is in a minute. But this is the Cartesian curve, and this is the polar curve. Now, one of the things that you will find with lantern manufacturers is that there is normally two ways to photometer the lantern. The first one is that you mount the fitting horizontally, if we look at this distribution here, and what this fitting has been photometered horizontally, and as a result the blue distribution is showing you the light coming out of the fitting, which is here, and we've drawn a section through the lantern and the distribution. So this is showing you that the output is coming out at probably about 50, 60, maybe 50 degrees, maybe 55 degrees perhaps. And then the red distribution is showing you the output left and right, as if you were looking straight out from the fitting and looking at what's going left and right of the fitting. So it gives you an indication of what's going on. Now, coming back to the original photometry I was looking at, which is one of the Abacus fittings. Abacus photometer their floodlights, and they produce the data with the output at the peak distribution of the fitting. So what you would need to do is that if the output of the fitting was say 55 degrees, you would need to tip the fitting up to 55 degrees to effectively get that distribution horizontal, so as if the fitting was mounted horizontally. So there's a little bit of understanding between what's going on, between how the manufacturers photometered it and what's going on. So I have to say this is not the exception. This is the exception rather than the rule. The majority of manufacturers will photometer their floodlights horizontally, as we've got here. Here's another example. This is the Philips Optivision lantern. So, and that's exactly the same. These are all metal halide floodlights. So you can see how those distributions are. So the blue distribution is showing you how far the light will come out of the fitting when it's mounted horizontally in this case. So in this case the peak distribution is at 60 degrees, and you do your trigonometry thing and work out how far that would be going across the court or the pitch or whatever it happens to be. So one of the other things that we come across from time to time is not that one. Which one was the one I was looking at? Is it C? Nope. Maybe it was E. So this is a situation with a floodlight that was actually part of a design that one of our users sent through. And what I'm going to do is position that in the middle of the pitch. I've set up a calculation grid here. Incidentally, there's 2 or 3 ways that we can set up our calculation grids for sports lighting. The first thing you can do is to contact the association. So in the UK, for example, for football, you might look at the FA's website, or Sport England, and they have recommendations as to what calculation grids and levels and so on should be used. I tend to use BS 12193 because it's an independent standard. It's a British standard, and that gives you recommendations for how you should set the columns out. So for football, it's telling you the dimension of the playing area and what the grid spacing should be along the length and across the width. Now, I have always been of the opinion that the more calculation points you've got on an area, I think this uses the 12193 arrangement where I used 21 by 15 points. Yes, I did. So the alternative to that is to use the FA use an 8 by 11 grid, which, if I'm honest about it, I don't think there's enough points there. Obviously, the more points you use, the more accurate the uniformity is going to be, and the better it will look for the to the users. So something that's just worth considering whilst we're talking about that. So I'm going to position a column in the middle of the pitch, and I'm going to mount it at 15 meters. Now, as you can see with this distribution, the lantern is pointing to the right. But the distribution is pointing straight down, and this is a very common issue we see with asymmetric floodlights and particularly ones that have been converted between IES and ULUM DAT format. So there is issues with the specification of where the 0 point is in the fitting. So when we look at the fitting in plan view, we tend to specify the 0 point being straight up. So it's at 0 angles. So if you when you're looking at it, now there are some areas where the 0 point is at a different angle. This is especially true for one of the American standards, and if the lantern has been photometered in a particular way, then you can quite often get this this rotation shift, so that you get some very unusual distributions out of the fitting. So the first thing I do when I get some new photometry is I'll put one lantern into a design area, and I'll just position one of them and then look at where the light is coming out. But we in Lighting Reality, there's a couple of ways that we can correct that within the program. So obviously for photometry that's included within the manufacturer's distributions, we will take care of that for the suppliers. That's one of the things that we do look for data that's part of the subscription service that we provide. So but what we can do is use this rotate eye table option at the top here. So, and we can rotate the fitting around. In this case it's at 90 degrees, but it's extremely common to have a -90 shift on the photometry, in which case you would use the 270 option. In this case that's not the case, so what we can now do is we can now go and position that, and save that, and then we can position other columns to light our area to whatever level it is that's necessary, 270, and so on and so forth. So one of the things I would recommend is if you are looking at sports lighting, is to take a look at the mirroring system, the symmetry system that we offer. Again, anyone that does any sports lighting, that tends to be the way that you will design it. So you design it for a quarter of the pitch, and then those are mirrored into the other four corners, because obviously you would generally, as a rule, you would have the same arrangement in all areas. So I hope that has been useful. I've got a couple of things to ask of you. Firstly, if you found the video useful today, please can you like the video below? It helps me with my my rankings within YouTube. If you have any comments or questions, add these to the questions area below. Or you can message me through the YouTube channel. You can tweet me nicksmith1246, or you can email me support@nicksmithassociates.com. Please subscribe to the channel for future updates, so when I publish a new video, then you will automatically get a notification for that. And finally, if you have a topic you want me to cover, please message me through the channel, tweet me nicksmith1246 through Twitter, or you can email me support@nicksmithassociates.com. Thank you very much for watching, and I will hopefully see you again.